Hello everyone, welcome back. My name is Mr. Cobalt, and in this video we're going to go over how to calculate the coefficients of a general reaction based on reaction rates. So let's get into this. Okay, so what we're given here is generally reaction. It says consider the general reaction A plus B gives us C. The small letters are the coefficients, and of course, the large letters are just the substances, generic substances with generic coefficients. And we're asked to use the rate data over some time period delta t to determine a set of possible coefficients to balance the general equation. So here's the rate information that we're given. We're given that the change in A over time is 0.0080 moles per liter per second. The change in B over time is 0.0120 moles per liter per second. And the change in C over time is 0.0160 moles per liter per second. Okay, so how can we use this information to help us figure out what are some possible coefficients for this general equation? Well, the first thing you need to remember is that the rate of the whole reaction is based on or is related to the rates at which the different reactants and products are either being lost or formed or used or formed. So you'll notice here that the rate at which A is being used in the reaction is different from the rate at which B is being used versus the rate at which C is being formed in the reaction. Well, the rate of the reaction is just one rate, right? So the reaction rate is just what it is for all of these substances. So the reason why we see that the rate at which A and B are being used up is different from the rate at which C is being formed is because the coefficients are going to be different, right? So let's, for example, if I have, let's say the coefficient of A is 1 and the coefficient of B is 2, that would mean that even though the rate of the reaction is the same, regardless of what we're looking at, the rate at which A is going to be used up is going to be, how should I say, slower than the rate of which B is used up. If the coefficient of B is 2 and the coefficient of A is 1, that would mean that for every one A that's being used up, you're using up two B's. So let me just write that out. So let's say this is a 1, this is a 2. So what this means is that for every A that's being used up to form C, I am using up two B's to form C. That means that as the reaction is going, the rate at which I'm losing B is double the rate at which I'm losing A, right? So, but the reaction rate, the rate of the reaction as a whole is the same no matter what we're looking at. So we need to take in consideration how the rate at which the individual substances are being lost or formed into account for the reaction rate. So no matter what substance we look at, we should be able to calculate the reaction rate. And so we can use this by using the inverse of the coefficients in this way. So the reaction rate, I'll write it this way. So the reaction rate should be equal to the rate at which we are either losing or gaining, losing reactant or gaining product multiplied by the inverse of the coefficient, right? So whatever this reaction rate, it's going to be related to, so the change in A, right? So the change in A over time, but it can't simply be the equal to the reaction of the rate at which A disappears over time, because the change in B over time is different, right? So we got to take in consideration the coefficient. And so in order to get those equal to each other, we have to multiply by 1 over the coefficient. In this case, it would be A. So whatever the rate of the reaction is, it's going to be equal to the rate at which A disappears multiplied by 1 over the coefficient of A. This is also going to be equal to the rate at which B disappears over time, but also multiplied by the inverse of its coefficient, so 1 over B. So again, if we go back to 1 and 2 here, 1, how do we get these rates equal to the rate of the reaction, right? How do we get the same rate of reaction when we have different rates at which the substance is either disappearing or appearing? Well, we multiply by 1 over the coefficient. So here, if the coefficient is 1, then this would be 1. So 1 over 1 is 1. And then with this, it would be 2. So if we took the rate of the B at which B is losing, notice that B here is a 2, right? So if we divide this by 2, then the rate at which B is being lost is double the rate. But if we divide that by 2, then we get the same reaction rate. And again, this is equal to the change in C over time. And again, that's going to be multiplied by 1 over, oops. Let me move this over, give myself some space. So the change in C over time multiplied by 1 over C. So now to find possible coefficients, we just set these equal to each other and solve for the ratio of A to B and A to C and B to C. So we only need 2 of those. So let's take 1 over A times delta A over delta T. Since all 3 of these terms are equal to each other and they're equal to the same reaction rate, then we can take 2 terms and solve, right? So I'm going to take the first 2 terms. 1 over A times delta A over delta T is equal to 1 over B times delta B over delta T. We're given delta A over delta T. We're given the rate at which A and B are being lost. So we're going to plug those in. So 1 over A times delta A over delta T, which is 0.0080, 0.0080. And that's going to be equal to 1 over B times delta B over delta T, which is 0.0120. 0.0120. I'm leaving out the units because those are going to cancel out anyway. Now, if I solve this, I get, if I divide both sides by 1 over B, so that's going to cancel out. And then I divide both sides by 0.0080, 0.0080. So that cancels out. So I get 1 over A divided by 1 over B is equal to 0.0120 divided by 0.080. Well, that's going to be 1.5. So that's going to be equal to 3/2. Dividing by a fraction is the same as multiplying by its reciprocal. So this would be the same as b over 1 multiplied by 1 over a, which is equal to, again, 3/2. But multiplying these together, you just get b over a. So I get b over a is equal to 3/2. And then I cross multiply, so I get 2b is equal to 3a. And then I can solve for a. So then a divided by 3. So a is going to be equal to 2/3 b. All right, so let me put a box around that. Okay, so now I have that relationship between the coefficients a and b. I can do the same thing by comparing a to c and see what the relationship between a and c is. So let's go ahead and do that. So I'm going to go ahead and erase this. So I don't need this anymore. I'm going to put this up here. So a is equal to 2/3 b. All right, now for, what about a and c? So I set that up again. So 1a times delta a over delta t, right? Delta a over delta t is equal to 1 over c times delta c over delta t. Again, I know that delta a is 0.080, so 1 over a times 0.0080, that's going to be equal to 1 over c times, and delta c over delta t is 0.0160. 0.0160. And again, I do the same thing. So I'm going to divide both sides by 1 over c. So 1 over c cancels out. I'm going to divide both sides by 0.080. Oops. 0.0080. 0.0080. So this cancels out. And again, I get 1 over a divided by 1 over c is equal to, this is going to be 2 over 1. Again, dividing by the fraction is the same as multiplying by its reciprocal. So that's going to be equal to c over 1 times 1 over a, which is equal to 2 over 1. Bring this up here. So c, this is going to be basically c over a. So c over a is equal to 2 over 1. Cross multiply, and I get c is equal to 2a. Now, since I have a equal to 2/3 b, I want to get a by itself. So here, divide by 2. And then I get a is equal to 1/2 c. Okay, so now I have a equal to some fraction of b, a equal to some fraction of c. Since they're both equal to a, I can set them equal to each other. So now let me go ahead and erase this. Let me write a is equal to 1/2 c. Now to get the relationship between c and b, I just set those equal to each other. Since a is equal to this, a is equal to this, therefore they must be equal to each other. So two things equal to the same thing must be equal to each other. That's logic. Okay, so here I have 2/3 b is equal to 1/2 c. So now what I can do is I can divide both sides by 1/2. And so this will cancel out. Now divide both sides by b. So that'll cancel out, and I get 2/3 divided by 1/2 is equal to c over b. Again, dividing by a fraction is the same as multiplying by its reciprocal. So that means I have 2/1 multiplied by 2/3, and that's equal to c over b. So multiply those together, I get 4/3 equal to c over b. So now I have this relationship between b and c. I have a related to both of those, and now I can figure out what the relationships are for the three of them together. So all we need to do is figure out what the whole numbers are for a, b, and c that will give us the right coefficients or a possible set of coefficients. So here we just need to find whole numbers. So again, we're finding the coefficients. Remember, the coefficients in your balanced equation can't be fractions, but we can, if we end up with a fraction in one, then we can multiply throughout all of the coefficients to get rid of that fraction and get the lowest whole number ratio possible. So in this case, if a is equal to 1, right, then that means c would be equal to 2, since a is equal to 1/2 c. So in order for a to be 1, so if we make a equal to 1, then that means c would have to be equal to 2. So we have whole numbers there. What about now if we go to b here, right? Or we could use this here, it doesn't matter. So if we assumed a to be 1, c would then have to be 2. And then therefore, if we plug a is equal to 1 here, or we could plug in c is equal to 2 here, we should get the same answer, right? So if we put a is equal to 1 here and solve for b, right? So then that would mean 1 would be equal to 2/3 b. So if we multiply by the reciprocal, 3/2. So 2 would cancel out, 3 would cancel out. We would multiply this by 3/2. And so then b is equal to 3/2. If we do the same thing here, we could put c in for 2. So if we have 4/3 equal to c, so 2 over b. So we multiply by b, multiply by b on this side, b's cancel out, and then we will multiply by the reciprocal 3/4 and multiply by the reciprocal 3/4 over here. 2 would cancel out. Of course, 3/4 would cancel out with 4/3. We have b, so we'd end up with b is equal to, this would be 1, 2 cancels out with 4 to 2, and again, b would equal to 3/2. So 3/2, 3/2. So either way gives you the same number. So you have a equals 1, c equals 2, and b equals 3/2. So we can't have a fractional coefficient. So in order to get rid of the fraction here, we would have to multiply by 2. So if we multiply this by 2, we would get 3 for b. But when you're balancing your equation, if you multiply by one factor, if you multiply one coefficient by one factor, then you have to multiply the other coefficients by the same factor. So multiply a by 2. So 1 times 2 is 2. So a 1 times 2 equals 2. And then c is 2. So multiply that by 2. So c equals 2 times 2 equals 4. So b equals 3, a equals 2, and c equals 4. Oops. And c equals 4. So those would be one set of coefficients that would be possible for this generic equation. But then again, any factor multiplied. So I could multiply all these by 3. So as long as you have the same ratio, those would be the possible coefficients. I hope this was helpful. If this was helpful, if you enjoyed the video and learned from the video, then by all means, please like and share the video. Hit that like button over there. Also, do me a favor, please subscribe to the channel, hit that notification above, right up there somewhere, and then make sure you click all so you'll be notified by all the videos I put out. And finally, put a comment down below in the comment section. Let me know what you think. Ask me questions. I would love to hear from you. If you have a problem or a question you have, put that down below. If you have a topic you would like me to cover, let me know down below in the comment section. I would love to do that for you. Thanks for joining me and have a great day.